Hello. So in the previous video, I demonstrated how to use Excel pivot table function to make a frequency distribution table and a probability distribution table from the data. And it was simple, and it is really useful. I'm telling you, you don't need to know the theory that I'm teaching. Does not, like, as long as you can pass this course, but Excel is much more important in your career, so mind yourself. Anyhow, back to the slides. We learned how to make such a table, and this is what we get. And for one variable, in this case, it only has one variable, and you may consider two variables. I showed you how to do this, and you can do it by yourself. So this is two variables. By the way, two variables is the maximum number of variable is at most two to make such a simple distribution table. If you have three variables, you have to have at least three dimensions, or you have to have multiple two-dimensional tables. So in this course, we will consider two variables at most. But it's simple, it's straightforward to extend two variables into three variables. So I'm not going to consider more variables case. Anyhow, come back to this example. We are interested in health insurance variable and the gender variable. So we get this probability distribution table. Now let's think about the fundamental structure of this data and this randomness. In this data, how many outcomes are there in the sample space? Think about this. Can you think about this? As I said, I want you to answer this question. I will turn the page. The answer is 4, because think about the experiment. One experiment, I said, is one person, and which equals two answers. So because we are considering only two variables in here, from this table there are only two variables, so there are 4 possible combinations of answers like this: male with health insurance, female with health insurance, male without health insurance, female without health insurance. So there are two questions, and each question has two possible answers. So finally, there are 2 by 2, 4 possible answers. In other words, there are 4 different types of people in this table. You can tell from this table. So the answer is 4. Right? Okay, then in this case, when we have more than one variable or multiple variables, the probability of an event will be defined in this way. We are going to define the probability as the sum of probabilities of the outcomes included in the event. So for example, if you are interested in the probability of this event, so remember, event is a subset of the sample space. So any combination of the 4 outcomes, so an event contains some of these 4 outcomes. So like, for example, think about this colored outcomes. Suppose that you are interested in this event, then the probability is some of these guys, right? So then calculating the probability is first find which outcomes are included in that event, and second, add up all the probabilities for those outcomes. So that's the most fundamental way to calculate the probability. So definition of the probability, right? So then to understand this, you need to understand the difference between outcome and event. Remember, outcome is one element and an event is a set that contains some outcomes. So we have to distinguish them. And probability is can be attached to an event, right? So now we are going to define notation. Events, like in this example, I'm going to use F and H. F stands for female. H stands for having a health insurance. So, and the probability will be denoted as PR. Remember, probabilities can be understood as a function. Probabilities are functions defined on events. So if you input an event, then through the probability function, it returns a probability, right? It's a function. So probability of the event F, probability of the event H. So they are probability of F, probability of H. So any event can be expressed as a manipulation of those two basic events in this example, right? For example, then think about this. Female was denoted as F. Then how can we denote male? So now you are interested in probability of male. Then you may use this notation. So by definition, male, the event male is the set of all people who are not female, right? So in the set theory, we call such a set as the complement of F. So it collects everything not included in F. So we denote it as F complement, superscript C. So FC is the notation for male. So you do not need to define another notation for male. As long as if you have female, then male will be automatically defined. Similarly, H is for those who have health insurance. Then H complement are those who do not have health insurance. So because H complement is those who are not who do not belong to H, so not belong to health insurance covered group, then they are not covered. So that's complement. It's an operation. So when you have an event, you can generate another event using the complement operation. And then we can think about, we generated another event from the original event. Then we can think about the probability of the complement like this. What is probability of F complement? The answer is pretty simple. The answer is here, and the answer is the male. So F complement means male, not included in female. So in this case, I don't care whether he has health insurance or not. Health insurance is not of our interest. So this event only looks at gender variable, and in particular, we are looking at these groups, these type of people who are these two types, includes these two outcomes among these four. So these two outcomes fall into this event. So its probability is sum of these two probabilities. That's how we can calculate the probability of the complement. Right? It's quite simple, but actually this is the fundamental way to find the probability of the event. But there is a simpler way, like this. We call this complement rule. For any event A, suppose that there is an event A, right? So then you can simply divide the outcome sample space into two groups, where A is true and where A is not true, or A happens or not. You can understand it as A happens or A does not happen. And the group that A does not happen is exactly a complement, right? Then there are only two possibilities. The probability of A plus probability of A complement must be 100%, right? The probability must be perfectly divided into A and A complement, which means A complement is 100% minus the original probability. So it tells you that if you know the probability of the original event, then the complement, the probability of the complement also follows automatically. Pretty simple. So it's so intuitive. So it's hard. You don't need to memorize the name. It's so obvious. Okay. Okay. In the next slide, I will introduce more operations of events and how to find their probabilities. Okay, see you in the next video. Bye.